Okay, apply Trig and Pythag to solve 3D problems. Now, there is one lesson in this, and essentially just one for the entire thing. Draw and label. That will save you most of your troubles. I know a whole lot of you are going to be like, yeah, no, I can think about this, and I can just, yeah, it's this, yeah, done. And then sometimes it'll work, and fantastic, aren't you bright? But for the number of times that will kick you in the butt, it's not going to be so bright, and you're going to look a bit foolish. So, draw a picture, label everything, and then break it down into constituent parts. So, we're going to make a sunshade or a sun sail. These are the things that are, sometimes they're over sand pits and things. Doesn't really matter. It's going to be a triangle. Cool, it's going to be made, it's going to attach to the top of 3 different posts. Conveniently, these are called A, B, and C. So, the top of post A is 6 meters up. Post B is 7 meters up, post C is 9 meters up. Okay, the bases all form a right angle triangle with lengths 3, 4, and 5. Find the dimensions of the sunshade. Okay, well, that's not so nice and straightforward. We should probably draw a picture. Okay, we'll draw more than one picture at that. So I've got 1, 2, and 3. I'm going to call these A, B, and C. Okay, great. A was however tall it was, 6. So that's 6 up. B was 7 up. And C was 9 up. Okay, in fact, we better change that picture then. Now this is shorter. Cool, is that what I said? Yes, cool. Alright, these things connect in a right angle triangle. Well, I'm going to say that that is my right angle triangle there. So the bases of these things connect in a right angle triangle. In fact, yeah, no, that's right, we'll leave that. Cool, alright, so on one of these, and I should have stipulated this in here, which we can do now. We'll say that this is a C, this is BC, and this is, what's missing? AB? Yep. Cool, so 3, 4, 5. Fantastic, okay, I want to know the side lengths of this triangle on top. In fact, I'll get rid of that right angle, so it's not necessarily. Okay. Great, so we've got this, okay, what are we going to do? This is not at all supposed to be obvious about what's going on, so we should think a little bit more carefully. Do we even need all of this drawing? The short answer ends up being no, because the first 6 meters of everything, don't need it. You can just bring everything down 6 meters, none of the angles or sizes change. So let's think about that. So we're going to have now something like this, where this is on a post, this is on a post. In fact, hang on, let's change colour as well. So the purple is the sunshade, that's one post, that's another post, the other post is done. Cool, this has a height of 1, this post in here has a height of 3. That's terrible, 3. There. Beautiful, okay. On the ground, I've just realised I've changed that scale a lot, so let's fix that up a bit. This should be short side, this should be longest side. Okay, let's draw that again, because I want that still to be tilted up. So this is going to be shorter, this is going to be longer, this is going to be longest. There we go. So this is 1 meter tall, this is 0 meters tall, this out the back is 3 meters tall. Cool, the shadow that this thing is going to cast, if I look from directly above, is going to be whatever it was, 3, 4, 5, with that being the right angle. We have a lot of triangles involved here. Okay, I'm going to firstly pick the front triangle. Now, this becomes a bit tricky because we need, it's probably a good idea if we name things. I'm going to call these A, B, is that like that, and C. since those were the post bottoms. Okay, yeah, we'll do that. From there, we'll call these, what sounds like there's nothing? No. I'll call these P and Q for the tops. And is that all I need? Bang, bang, bang. 1, 2, 3, 4, 5. Yes, I've only got 5. That's cool. Cool, so top of the post and quite tall. Sure. You can pick whatever letters you want, doesn't really matter that much. Okay, so the first triangle I'm going to dissect out of this is ABP. So, draw with some colour so that we can keep some semblance of order. Cool, there's a 5. There's A, B, B. There's a 1. And we don't know this side, okay? Maybe I should give this a name at this point. We'll call that X. Go. I'll call this Y, and I'll call this Z. Cool, so this is side X. So that we don't get terribly lost, what do we ultimately want to know? Our answer is X, Y, and Z. They're all the side lengths. Cool, alright, can we get that from here? Well, yeah, this is just Pythag now, so that's fine. So 1 squared plus 5 squared equals X squared. So X equals the square root of, what's this, 25, 26. Done. Can we take anything out? No, 2 by 13. Done. Okay. Alright, 1 down, couple to go. Cool, I'm going to pick the back left side now, so A, Q, C. And again, you don't have to do this in that order, but I choose to. Blank. Cool, C, Q, A. This is 3, this is 3, this is Y. Cool, so we've got 3 squared plus 3 squared equals Y squared. So what's this, root 18? Which we can simplify, take out a 9, so we get 3 root 2. Beautiful. Okay, next bit. Okay, I've got a shape up the back. Now that's not a triangle. Okay. This comes down, that's the Z on top there. Q, P, A, B. Q, P, A, B. This is 1, this is 3. And the back is 4. Cool, so I've got this shape, fantastic. Well, that's a trapezium, but other than that, that's looking a bit fiddlier. Well, what I can do instead is go, oh, hang on, I'll just chop it across there instead. This is still 4. I've chopped off 1, so this inside here is now 2. Okay, well that's okay, now I can get my Z. 2 squared plus 4 squared equals Z squared. Z I should be saying, but anyway, 16, 4 root 20. So 2 root 5. It's a bit of fiddling. Cool. We've got it on our sides. Fantastic. So we can answer our actual question. Cool. This is root 26 meters. Y is 3 root 2 meters. And Z is 2 root 5 meters. Fantastic. Okay, well that's the side length dimensions. What if instead I now change the question to say, find the area. And now we have a slightly bigger problem because we've got these sides, but unless you've done for, which one was it? FGH I think it was, which had Heron's rule in there. Unless you've done that, you don't know how to get it from the sides. So we're going to need to do a little bit more work. Okay, let us do the do we want to do it that way or do we want to do it a different way? We could do it either. Yeah, that's right. Cool, alright, so we've got our sunshade. This is definitely a triangle of some sort. I am going to pick that this is Z up the back, so that's 2 root 5. Y over here, which was 3 root 2. And X, which was root 26. Okie dokie. Can we get any more information out of this? We do this, we do this. herons would be a lot faster. I'm going to end up proving Heron's rule if I keep going from here. So I might change what I was asking. Yeah, I'll change what I'm asking, sorry, to get the area. You can do it, but it's going to end up being outside of what I actually want to do. So find the angle of elevation from the top of post A, post A to the top of the other posts. Angles of elevation. Okay. So what am I talking about there? We want to go from point A to point Q and look at that angle. Okay, so I'm going along Y. So I'm going from A to Q along Y, so I want that angle there, so that's one of them. In fact, I'll call that alpha. And the other one from A up to B, sorry, A up to P rather. So I'll call that beta. Cool. Now, why is this an angle of elevation? Remember that A, we're looking up to Q, so that's that guy, and for the other one, we're looking up to P. These are different angles. Okay, so alpha, we've got this a couple different ways. I'll use the 3s because it's easier. Tan of alpha equals opposite over adjacent. Cool, so tan inverse, 3 on 3 equals alpha. Chuck that into a calculator. It'll spit out 45 degrees exactly. Cool, so that's one. Other one. Tan of beta equals opposite over hypotenuse. So tan inverse of 1/5 equals beta. Beta equals some terrible number. Tan inverse, tan inverse. There we go. 1 on 5, 3 degrees, yes. 11.311-ish. 11.3099. Okay. Excellent. So we've got those two angles. Okay. Now my next question is just going to be, okay, what's the angle starting from P, looking up at Q? Now that may or may not be interesting, so we'll find out. Okay, from P to Q would be this angle here, which I'm going to call gamma. Okay, so we've got tan gamma equals opposite 2 over adjacent 4. So tan inverse of 2 on 4, you could change it to a half, doesn't really matter. Gamma roughly equals something terrible. 26.565. Cool, all of these are in degrees. Now, is it obvious that that's what our result was? We might have said, oh hang on, isn't it just going to be this minus this? But 45 minus 11, that doesn't match. You've got to be careful about this because you're in different planes, right? One's looking up there, one's looking out here, this other guy's looking up there, right? There is no reason that those should add up. So you've got to be a little bit careful about any assumptions that you make. But all of this just broke down to really simple Pythag and Trig. The trick to that is purely draw a picture. The first one is probably going to be a little bit rubbish, that's fine. You can either draw it in pencil or just draw again. Usually drawing again is a pretty good idea. Draw a nice one with things labelled, okay? Very good idea to label corners in these, right? Figure out what you actually want, give them names, that also helps, and then just break things into pieces. It's sometimes even best to go, okay, I'm going to do this piece, don't actually solve it, leave some space and go, cool, once I've got that, then I'm going to do this, leave some space, then I'm going to do this, leave some space, and so on. But you can just do it bit by bit if you want as well, that's totally fine. Most of these are not terribly tricky in the actual math part, it's just the setup. which will become a running theme for so many things.
Cool. Best of luck. Email me if you get stuck.